Hi class, this is Maddie and Cecile, and today we're going to be talking about Zipfian distributions in whales. Is whale communication more like human language or human song? Why does it matter? Whale songs, primarily sung by males to attract mates, are not only hauntingly beautiful but also follow fascinating patterns. So what do we want to do with this? In this presentation, we'll explore how both human and whale communication align with Zipf's law, a principle from linguistics and information theory. Why do we want to see this? Well, by analyzing Zipfian distributions in whale songs and human speech, we aim to understand whether whale communication is structurally more like human language or song. This comparison will help us consider what makes communication language-like and what it reveals about the evolution of intelligent signaling systems. So, what is Zipf's law? Zipf's law is a probability distribution power law. Something as complex as language can be simplified into the following equation, seen on the slide, which might look kind of crazy. The 10 most used words in the human language are the following: the, of, and, to, in, is, I, that, it, and for. The law basically says that the most common word, so the, occurs twice as often as the next most common, which is of, and three times as often as the third, which is and so on. But why do we make use of these short words so much? Well, it comes down to two things: conveying a message in simple terms and using the least effort. Essentially, our ancestors were lazy and trying to get to the point. Most used words are often only one syllable, and examples of those are because, about, and people. The big message is sometimes simplest can be best. Now, how about humpback whales? A study conducted in 2018 by humpback whale researchers explored striking similarities between the time frequency spectrograms of humpback whale songs and voiced human speech, suggesting a potentially common phonetic basis. The research proposes and tests a method for analyzing the subunit structure of humpback whale song units based on principles of digital communication and information theory, similar to the analysis of human speech vowels. The study uses statistical analysis, Zipf's law, to evaluate the characteristics of the identified humpback subunit set and compare it to the human language phenom set. The findings challenge the perception of humpback songs solely as musical expressions, providing evidence for underlying phonetic complexity akin to our language. The main conclusions were: the study by Howard Pines presents strong evidence grounded in digital communication and information theory that humpback whale vocalizations possess a complex phonetic structure comparable to human speech. The identification of 60 distinct subunit symbols organized into a symbol constellation and adhering to Zipf's law challenged the traditional view of humpback songs as purely musical. This research significantly expands the potential size of the known humpback song lexicon and suggests that their vocalizations function as a sophisticated form of communication with underlying principles similar to natural language. The cumulative probability versus ranked frequency distribution profile of the humpback subunit symbol set is nearly identical to that of the English language phonemes and conforms to Zipf's power law. The research states that Figure 7 clearly shows that a plot of the humpback subunit set's cumulative probability versus ranked frequency distribution profile is nearly identical to the same plot for English language phonemes. Both profiles conform to the Zipf's power law signature geometric probability distribution profile for natural language symbol sets exhibiting pronounced information redundancy.
Subsequences found in whale songs, which can be seen as words in human language, follow Zipf's law of brevity. Zipf's second law, or the law of brevity, demonstrates that frequent words tend to be shorter than infrequent words, so it shows the relationship between length and frequency. Using infant-inspired segmentation methods, researchers were able to show that subsequences from whale songs also follow this law. In other words, frequent subsequences in whale songs tend to be shorter than less frequent ones. Here's a graph to illustrate this. So each point on the graph is a subsequence, and the figure shows the frequency distribution of all subsequences discovered by the infant-inspired segmentation method plotted by the length, so the number of sound elements. More frequent subsequences are shorter than less frequent ones, indicating that the subsequences not only follow a Zipfian distribution, but also follow Zipf's second law. We can clearly see a strong relation between frequency and length. This was assessed using a Poisson mixed effect regression. The Poisson regression line is shown here in blue. The hierarchical structure in humpback whale song and human language are very similar. Whale songs are composed of multiple themes, which can be seen as sentences. Themes are composed of multiple phrases, which can be seen as words, and phrases are composed of sound units, which can be seen as phonemes. So whale song structure is analogous to the hierarchical structuring of human speech and song, and this hierarchical structure facilitates cultural learning in whales. So humpback whale song follows a Zipfian distribution and Zipf's second law, the law of brevity. Furthermore, whale songs have a similar hierarchical structure found in human language. Human language and whale song are both culturally transmitted, and the combination of Zipf power law and the hierarchical structure facilitates cultural learning of whale songs. Humans and whales are evolutionary distant species, however, they have commonalities which were thought to be unique to human language. This offers a comparative view with human communication and possibly also on the evolution and emergence of certain aspects. So, what could possible future research in this field be? For one, we could look at other culturally transmitted sequential behavior and check for similar statistical structures. This research also showed us that we can benefit from looking at evolutionary distant species and convergent evolution. So maybe we should not only look at primates when looking at the evolution of language and music, but also consider other animals, because they might also have unexpected commonalities with humans. However, are whale songs more similar to language or music? As we saw, whale song exhibit patterns that follow power laws found in human language and also seem to have a similar hierarchical structure. All of this helps cultural transmission and language learning. But whale song does not seem to convey meaning as seen in human language, so maybe it should rather be compared to human music rather than language. What do you think? These are the resources we used, and thank you for your attention.